Imagine walking through the darkest forest on a moonless night. The world around you is pitch black, silent except for the rustling of leaves in the wind. You strain your eyes, but nothing is visible. Then, click. With the flick of a switch, the landscape suddenly glows green. Trees appear from the darkness. The ground is alive with movement. In the distance, a pair of glowing eyes watches you. This isn't magic, it's night vision technology. But how does it actually work? Night vision allows us to see in the dark by amplifying the tiny amounts of light that are still present, even when it seems completely black. This is called image enhancement. Even in the darkest places, there's usually some light from the moon, stars, or distant artificial sources. Night vision devices collect these tiny traces of light and magnify them thousands of times, turning an invisible world into a glowing green image. But there's another way to see in the dark: thermal imaging. Instead of using light, it detects heat. Every object, whether living or not, gives off some level of infrared radiation, a type of energy invisible to the human eye. The warmer something is, the more infrared radiation it emits. Special cameras detect these heat patterns and translate them into an image, where warmer objects appear brighter and cooler ones darker. This is why thermal imaging can be used even in complete darkness, through smoke, fog, or dense vegetation. The most common night vision devices use image intensifier tubes, which rely on a fascinating process. When light enters the lens, it hits a photocathode, a special surface that converts photons, particles of light, into electrons. These electrons are then accelerated and passed through a microchannel plate, a tiny glass structure that multiplies them by the thousands. As the electrons exit the microchannel plate, they strike a phosphor screen, which converts them back into visible light. The result is a bright green image that allows users to see details they could never detect with the naked eye. But why green? The answer lies in human biology. Our eyes are more sensitive to green than to other colors, meaning we can see finer details in shades of green than in blue or red. Additionally, green is less straining for long periods of viewing, making it ideal for military operations, law enforcement, and search and rescue missions. Night vision has advanced tremendously since its early days. The first crude devices, developed during World War II, were bulky, required infrared spotlights to function, and had limited range. Over time, improvements led to smaller, more effective equipment that could work with ambient light alone. Today's night vision is so advanced that some devices even combine image enhancement with thermal imaging, allowing users to switch between modes or overlay both views for maximum visibility. This technology isn't just used by the military. Law enforcement officers rely on it for surveillance and search operations. Firefighters use thermal imaging to locate people trapped in smoke-filled buildings. Wildlife researchers study nocturnal animals without disturbing them. Even in pop culture, night vision plays a role, from military video games to spy movies, where operatives slip through the shadows, invisible to the naked eye but clear as day through their goggles. Think about it. What if you had night vision? What would you use it for? Would you explore a dark forest, track animals, or see what's happening outside right now? Try stepping into a dark room and letting your eyes adjust. How much can you really see? Imagine how much more would be visible with the right technology. Despite its incredible abilities, night vision does have limitations. Image enhancement depends on some level of light, so in absolute darkness, it won't function without an infrared illuminator. Thermal imaging, while excellent for detecting heat, cannot capture fine details like facial expressions or written text. And for civilians, access to high-end night vision is often restricted. Still, the ability to see in the dark has changed the way we interact with the world. What was once the realm of science fiction is now an essential part of modern life. Soldiers on the battlefield, researchers in the wilderness, and even firefighters in smoke-filled buildings rely on it. So the next time you find yourself in complete darkness, remember, just because you can't see something doesn't mean it's not there. The night is never truly black. It's just waiting to be seen.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.